Hello students. So in this video, let's solve problems based on trigonometric identities. So in the previous video, we had discussed the rules to solve the problems. So let's recall the rules. Let's look into the rules once again. So the rules are, the first rule is to check if any trigonometric identities are there. If it is there, we are going to use it. If it is not there, then we are going to convert all the trigonometric ratios in terms of sine theta and cos theta. Okay, how do we convert? For example, if you have got tan theta, make use of the quotient relation. Tan theta can be written as sine theta by cos theta. If you remember the quotient relation, cot theta can be written as cos theta by sine theta. What about the others? If it is cosecant theta, we are going to use the reciprocal relation, that is 1 by sine theta. And if it is secant theta, you're going to write it as 1 by cos theta using the reciprocal relation. This is what we are going to do. This is how we convert it. Once we convert it into sine theta and cos theta, we must take LCM. And if you take LCM and simplify it, definitely we will get a trigonometric identity. TI stands for trigonometric identity. AI stands for algebraic identity. Okay. So you will either get a trigonometric identity or algebraic identity. Use it, you will get the final answer. Okay. Now let's get into the first question. Okay. As you can see, we have to prove the identity, that is cosecant theta minus cot theta the whole square is equal to 1 minus cos theta by 1 plus cos theta. So here what we are going to do is we're going to take the LHS always and we're going to try to end up at RHS. That's what we are going to do. Or sometimes we can also take the RHS and end up at LHS. Okay. So let's start with the LHS. So as you can see, what is the LHS here? The LHS here is cosecant theta minus cot theta the whole square. Now, is there any identity cosecant theta minus cot theta whole square? No. What the identity that we have got is cosecant square theta minus cot square theta equal to 1. This is the identity that we have. But there is no identity cosecant theta minus cot theta the whole square. Okay. Or here, as you can see, it is in the form of a minus b whole square. You can also use a minus b whole square and solve it. Or the better way is, what we are going to do is, we are going to convert. See, as you can see, there is no identity. We are going to convert everything into sine theta and cos theta. So therefore, okay, so cosecant theta using the reciprocal relation can be written as 1 by sine theta minus cot theta using the quotient relation can be written as cos theta by sine theta, and the square outside as it is. Now, after converting into sine theta and cos theta, we must take the LCM. Here, both the denominators are same, so you can write it once, and the numerator will become 1 minus cos theta. Okay, 1 minus cos theta, the whole square. Now, if you observe carefully, what we need in the RHS is 1 minus cos theta by 1 plus cos theta, isn't it? Now, if you observe carefully, 1 minus cos theta is already available here. We have already got it in the numerator. But in the denominator, we have sine theta. I'm sorry. In the denominator, we have sine theta. But what we need is 1 plus cos theta. So how we want to get it? Very simple. First, what we'll do is we'll split the powers for the numerator and denominator. So I can write it as 1 minus cos theta the whole square divided by sine square theta. Sine theta the whole square is what? Sine square theta, isn't it? Now, the next step, I'll not do anything to the numerator, because in the numerator, we need 1 minus cos theta. It is already available. So let's not do anything to the numerator. Let's keep it as it is, 1 minus cos theta the whole square. What we have got in the numerator is sine square theta. But remember, I don't want the sine theta in the denominator. What I want is 1 plus cos theta. So very clearly, I have to convert the sine square theta in terms of cos. Okay. Is there a possibility? Yes, it is possible. How? Using an identity. If you remember an identity, it says that 1 minus cos square theta can be written as sine square theta. This is the identity that I'm going to use. So sine square theta can be written as what? 1 minus cos square theta. Now in the next step, 1 minus cos theta the whole square. See, the 1 can be written as 1 square, isn't it? Minus cos square can be written as cos square itself. Now, why did I write 1 as 1 square? Because if you observe in the numerator, I don't want the square. I have to eliminate it. I can eliminate it. How? See, 1 minus cos theta the whole square. The denominator now is in the form of a square minus b square, isn't it? A square minus b square is what? A plus b into a minus b. If you observe, it is in the form of, the denominator now is in the form of 1 square minus cos square theta. So it is like a square minus b square, where a is 1 and b is cos theta. So 1 square minus cos square theta will become, a square minus b square will become a plus b. That is 1 plus cos theta into 1 minus cos theta. Now you can cancel 1 minus cos theta and 1 minus cos theta one time. Therefore, what you are left out is 1 minus cos theta divided by 1 plus cos theta. Very easy one. Okay. Let's get into the next question. You can take this question as a task and try it out. Secant theta minus tan theta. You can do it the same way. Secant theta minus tan theta, the whole square, is equal to 1 minus sin theta by 1 plus sin theta. Exactly the same procedure. Okay, here, if you take the LHS, what do you get? Secant theta minus tan theta, the whole square. So there is no identity converted. So it becomes 1 minus cos theta sin theta by cos theta, the whole square. Now take LCM. If you take LCM, it becomes cos theta. Numerator is 1 minus sin theta, the whole square. Now split the squares. There is split the powers, 1 minus sin theta, the whole square by cos theta, the whole square, which becomes cos square theta. Now, I don't want cos theta in the denominator. I want sin theta. So cos square theta can also be written as 1 minus sin square theta. And 1 minus sin square, this 1 can be written as 1 square. 1 square minus sin square theta can be written as 1 plus sin theta into 1 minus sin theta. So 1 minus sin theta, 1 minus sin theta gets cancelled. So what we are left is 1 minus sin theta by 1 plus sin theta. So I hope you understood this. Let's get into the next question. Same way, what we are going to do is we are going to take the LHS first. So in this question, what is our LHS? Our LHS is cos A by 1 plus sin A plus 1 plus sin A by cos A. Okay. So here, as you can see, there is no identities, isn't it? Do we have an identity for 1 plus sin A? No. We don't have any identities. So if you don't have any identities, what should we do? We have to convert into sin and cos, sin theta and cos theta, or sin A and cos A. But if you observe this question, everything is in terms of sin theta and cos theta. That is, everything is in terms of sin A and cos A. So there is no need to convert it into sin A and cos A. Okay. Then what will be the next step? After converting into sin A and cos A, here, which is actually already in terms of sin A and cos A, what we have to do? We have to take LCM. So let's take the LCM. How do we take the LCM? Let's do the shortcut method, that is multiply the denominator. So 1 plus sin A. There are two terms, so I'll put a bracket. 1 plus sin A into cos A, isn't it? Multiply the denominators, then crisscross, isn't it? So cos A into cos A will become cos square A plus 1 plus sin A. This first we multiply the denominators, then crisscross, cos A into cos A. Next thing is 1 plus sin A into 1 plus sin A. So A plus B into A plus B. 1 plus sin A into 1 plus sin A is 1 plus sin A the whole square. Remember, A plus B into A plus B is A plus B the whole square. Now, let's keep the denominator as it is. Let's simplify the numerator. Cos square A as it is plus, if you observe, 1 plus sin A the whole square is like A plus B the whole square, where A is 1 and B is sin A. So what is A plus B the whole square? A square plus B square. B is sin. So B square plus 2AB. Okay, I'm just using A plus B the whole square formula. The denominator as it is, 1 plus sin A into cos A. Now let's simplify it. Cos square A, 1 square is 1, plus sin square A is sin square A itself, plus 2 into 1 into sine A is 2 sine A divided by 1 plus sine A into cos A. Now, let's rearrange the numerator a bit. Cos square A, after cos square A, let's write sine square A. Cos square A plus sine square A plus 1 plus 2 sine A. The denominator as it is. 1 plus sine A into cos A. Now, if you observe the numerator, we have got an identity here. Cos square A plus sine square A. What is cos square A plus sine square A? Or sine square A plus cos square A? Both are one and the same. So it is 1. 1 plus 1 plus 2 sine A divided by 1 plus sine A into cos A. Now what is 1 plus 1? 2. 2 plus 2 sine A divided by 1 plus sine A into cos A. Remember, you are not supposed to add this 2 and this 2 because this 2 is along with sine A. Okay, so this is like a different term. This is a different one. So you're not supposed to add it. Okay. Now what you can do is you can take 2 common. If you take 2 common, 1 plus sine A divided by 1 plus sine A into cos A. So if you observe carefully, 1 plus sine A, 1 plus sine A gets cancelled. So the thing that we are left out is 2 by cos A. 2 by cos A can actually be written as 2 into 1 by cos A, isn't it? So 2 into 1, 2, cos A as it is. So 2 by cos A can be written as 2 into 1 by cos A. What is 1 by cos A? It is secant A. So we have got our RHS. So we have just followed the procedure. What was the procedure? There was no trigonometric identity, so convert everything into sine and cos. But it was already in terms of sine and cos, so we took LCM directly. Once we took LCM and simplified it, we got an we got an algebraic identity in the numerator. We simplified that, we got an trigonometric identity. That is cos square A plus sine square A is 1. Then again on simplification, we got the RHS. So let's get into the next question. A very, very important question. So as usual, let's take the LHS. The LHS is tan theta by 1 minus cot theta plus cot theta by 1 minus tan theta. Okay. Now, they've already given us the hint. Write the expression in terms of sin theta and cos theta. So as you know, there is no identity, isn't it? We don't have any identity. 1 minus cos theta, 1 minus tan theta. There is no identity. If there is no identity, what should we do? We have to convert in terms of sin theta and cos theta. Okay. So tan theta can be written as sin theta by cos theta divided 1 minus cot theta can be written as cos theta by sin theta. Okay. Plus again cot theta can be written as cos theta by sin theta divided by 1 minus tan theta can be written as sin theta by cos theta. Okay. So here sin theta by cos theta as it is. Let's simplify the denominator. Okay. Here this one can be written as 1 by 1. Similarly, this one can be written as 1 by 1. Let's take the LCM. 1 into sin theta, then crisscross. 1 into sin theta is sin theta minus 1 into cos theta is cos theta. What we have got is on simplification sin theta minus cos theta by sin theta. Same thing we'll do it here. Cos theta by sin theta. Again, 1 into cos theta is cos theta. 1 into cos theta minus 1 into sin theta is sin theta. First multiply the denominators. then crisscross. That's what we have done. Okay. So in the next step, if you remember, if anything is in the form of a by b divided c by d, you've done it many times. A by b divided c by d. What do you do? A by b, the distribution becomes into d by c, isn't it? You take the reciprocal. Same way. So here a by b is sine theta by cos theta. C by d is sine theta minus cos theta by sine theta. If you observe, it is in the form of a by b by c by d. So what we are going to do is a by b sine theta by cos theta as it is into the reverse. So it will become sine theta by sine theta minus cos theta. There are two terms, so let me put a bracket. Plus same thing here, a by b cos theta by sine theta as it is into cos theta by cos theta minus sine theta. Okay. So in the next step, as you can see, sine theta into sine theta will become sine square theta, isn't it? Let me write it here. Okay. Let me draw a line and continue. So sine theta into sine theta will become sine square theta divided by cos theta into sine theta minus cos theta. Okay. Plus cos theta into cos theta, cos square theta divided by sine theta into cos theta minus sine theta. Now at this step, what usually we have to do is we have to take the LCM. See, still we have not simplified it. We have to take the LCM. Okay, because there are two terms. We have to take LCM. How do we take LCM? We'll multiply the denominators, then crisscross. But here we can make it bit simple. Okay, that is, if you observe the denominator here, okay, what you have got is cos theta multiplied by sine theta minus cos theta. Here sine theta is multiplied by cos theta minus sine theta. If you observe these two things, this is sine theta minus cos theta. This is just the reverse, cos theta minus sine theta, isn't it? So I can make them same. So how do I make them same? I have to just take minus common here. If I take minus common, or to make it very, very simple, what we have to do is sine square theta by cos theta into sine theta minus cos theta. Okay. Here we have got cos square theta by sine theta. If I have to just reverse this, sine theta minus cos theta, I have to just change the sign. What was the sign earlier? Plus, just make it minus. Okay. Now, actually, what we will be doing here is, let me explain it properly. We'll be taking minus as common. If I take minus as common, minus 1 as common, so this becomes minus cos theta plus sine theta. If you multiply it, you get back the same thing. This minus cos theta plus sine theta can be written as sine theta minus cos theta. And this minus 1, which is in the numerator, okay, if you get it to the numerator, plus into minus will become minus. Okay, that's the logic. But let's remember it in a very simple way. If you are changing this sine theta minus cos theta, okay, and what is multiplied to it? Sine theta. This sign just changes to minus. Okay. Now, if you observe, there is a common thing in the denominator, sine theta minus cos theta, sine theta minus cos theta. So let's take it outside. So since it is in the denominator, sine theta minus cos theta, I have taken it as common in the denominator. So numerator will be 1. What is left out? Sine square theta by cos theta minus cos square theta by sine theta. I've just taken sine theta minus cos theta as common. Now inside this bracket, let's take LCM. Okay. So 1 by sine theta minus cos theta. How do we take LCM shortcut method? Multiply the denominator. Cos theta into sine theta, cos theta, sine theta. Crisscross. Sine square theta into sine theta is sine cube theta minus cos into cos square theta is cos cube theta. Now, if you observe, okay, it is sine cube theta minus cos cube theta is like a cube minus b cube, where your a is sine theta and b is cos theta. What is a cube minus b cube? A minus b, a squared plus b squared minus ab. This is the formula. So let me use that. Okay. So what do we get? 1 by sine theta minus cos theta. A cube minus b cube. A cube minus b cube is a minus b. That is A is sine theta minus B is cos theta into A square, that is sine square theta, plus B square is cos square theta, minus AB. So it becomes minus sine theta cos theta. Okay. Let me shift it a bit. So divided by, I've just used A cube minus B cube formula. Divided by cos theta sine theta. Now this sine theta minus cos theta, sine theta minus cos theta gets cancelled because they're in multiplication. So therefore, the left out thing is sine square theta plus cos square theta minus cos theta sine theta divided by cos theta sine theta. But we know that sine square theta plus cos square theta is 1. So 1 minus cos theta sine theta divided by cos theta sine theta. Still we have not got our answer. So what I'm going to do is, I'm going to split the denominator for both the terms. That is, if you observe the denominator, there is only one term. You can give it to both the terms in the numerator. Cos theta, 1 divided by cos theta sine theta minus cos theta sine theta by cos theta sine theta. Cos theta sine theta, cos theta sine theta gets cancelled. So we are left with 1. And this can be written as 1 by cos theta sine theta can be written as 1 by cos theta into 1 by sine theta, isn't it? What is 1 by cos theta? Secant theta. What is 1 by sine theta? It is cosecant theta minus 1. Okay. Yeah. Okay, I made a small mistake. Yeah, it is plus AB. The formula A cube minus B cube. A minus B, A square plus B square plus AB. Okay, I'm sorry. Sorry about that. So everywhere it is plus. You will get the identity now. So secant theta cosecant theta plus 1. Or you can also write it as 1 plus secant theta cosecant theta. Okay, I'm sorry with the formula. It is A minus B into A square plus B square plus AB. So what we have done here is, let me recall what we have done in this problem. See, earlier we didn't have any identity here, isn't it? In this step, we didn't have any identity. So we converted everything into sine theta and cos theta, and we have written. And if you observe the individual term, we must take LCM in the denominators. So that's what we did. We took the LCM. So on simplification, what we got is sine theta into sine theta sine square theta, cos theta into sine theta minus cos theta, plus cos theta into cos theta cos square theta, and this term sine theta into cos theta minus sine theta. Now here we had to take LCM. In this step, we had to take LCM between this term and this term. That's what we had to do. But if you observe carefully, the LCM can be much easier. Okay, it can be done much easier because here you got sine theta minus cos theta. Here it is just the reverse, cos theta minus sine theta. So what we did was, we just reversed this. Since we reversed this plus will change into minus. Okay, and I've explained it how it is. Okay, now if you observe here, sine theta minus cos theta are same. Okay, so I can take as common. After taking common, in the numerator we have got sine square theta, in the denominator it is cos theta. Okay, and similarly here in the numerator it is cos square theta, denominator is sine theta. So we took common and we have written the left out things. In the left out things we have taken LCM. So using the shortcut method, after taking LCM we've got sine cube theta minus cos cube theta, which is like A cube minus B cube. So what is A cube minus B cube? A minus B, A square plus B square plus AB. So we use that formula. On simplifying it, we got the required result. A very, very important formula. Okay. In the next video, we'll continue with the next problem. Thank you, students.